All right, ladies and gentlemen, so let's review solving systems of linear equation by graphing. So we are going to be just giving a minute for the internet to cooperate with me. So let's get started. So there's today in class we only did one example. Today's video lesson is short and sweet because we practiced mainly how to solve systems by graphing, and we did this example. So there are three methods of solving systems of equation: graphing, and when we talk about solving systems of equation algebraically, we talk about elimination and we talk about substitution. So today's equation is going to be on substitution. So let's review the example. So we're going to solve systems of equation by substitution. So let's go ahead and hopefully be able to text that. Solving systems of equation by substitution. So solving systems of equation by substitution. And the example that we had in our book. So before I do that, there are three steps involved in solving equations by substitution. Number one is to solve one of the expression for one of its variable. Number two is to substitute the expression from step one into their equation. So substitute, let's just leave it at that. Substitute. And three would basically be to find the missing variable. I'm kind of summarizing it a little bit, or to find the other missing variable. I'm summarizing it or paraphrasing it from your textbook. And let's just go straight into the example. So in your textbook, the example that is given to you is the equation 2x plus 5y equals negative 5. Actually, let me clear all the drawings, okay? That way. So what I'm going to do is I'm going to put into perspective everything, and we're going to go straight into substitution. So 2x plus 5y equals negative x equals negative 5, excuse me. And the second equation says x plus 3y equals 3, or x minus 3y equals, excuse me, x plus 3y equals 3. I apologize for that. X plus 3y equals 3. So pretty much what's going to happen here is the first step is to solve for one of the variables. I can either solve for x or I can either solve for y. Technically, if you decide to solve for either x or y, you will not have a different answer because they're linear. You're going to get the same answer. It's just that I prefer to solve for the variable or prefer to look at both equations. And if I have one of the variables in which the constant in front of it is a 1, I'll probably solve for that one because it makes it easier. So if I look at 2x plus 5y equals negative 5, I realize that the 2x and the 5y both have numbers or constants in front of them that are greater than 1. So it's not that I can't solve them, it's just that it'll probably be longer. And if I look at the second equation, I realize that x has a constant of 1. So technically this is just a 1x, but we don't write it. And we have 3y. So it just makes it easier to solve for x in this case. But again, if you decide to solve it for y, you will get the same answer regardless. So I'm going to go ahead and say x plus 3y equals -3. So I'm going to go ahead and solve that for x. And what I do is I solve this for x, and then I use that expression to find one of the variables, all right? So x plus 3y equals 3. Basically, what I'm going to do is I'm going to subtract by 3y or move the 3y to the other side, however you prefer. Okay, so x minus 3y equals 3. And I'm sorry. So I subtract. No, I apologize. I lost control of this for a minute. I'm sorry. So x, and then basically, well, this is going to cancel out. And that's going to leave me with x equals 3 minus 3y. So I'm done solving for x. I don't know the value of x yet. And the reason I don't know the value of x is because I don't know the value of y. So I did step 1, which in this case was to solve for x. Now, step 2 is to substitute. Now, what am I going to substitute? Well, I'm going to substitute the expression that I just obtained. So I'm going to substitute the expression that I just obtained into one of the two equations. I could technically plug this in here, or I could plug it in here. Now, it's just easier to substitute it into the first equation. So I'm basically going to take x equals 3 minus 3y, and I'm going to plug it in to the first equation, to the 2x plus 5y equals -5. And that's going to help me first find the value of y. And once I have the value of y, in this case, I can find the value of x. So again, step 2 is just to substitute. So instead of writing 2x plus 5y equals -5, I'm going to change that. So instead of writing this, 2x plus 5y equals -5, I'm actually going to turn that into the following equation. So again, I'm going to take this equation right here, or this expression right here, and plug it in to this equation. So basically, I'm going to take what I got from x, and I'm going to say 2 times 3 minus 3y plus 5y equals -5. So what I'm going to do is I am going to multiply everything. And I'm going to say, I'm going to use the distributive property. So I'm going to say 2 times 3 and then 2 times 3y, okay? So basically what's going to happen here is you're going to say 2 times 3 is 6. And then 2 minus 3y is going to be 6y. So you're going to have 6 minus 6y. And then you're going to bring down the other part of the equation. Let me move this to have some space, and then we'll rearrange it. So basically, plus 5y minus 5, I bring that down, plus 5y minus y, or equals -5, excuse me, not minus 5, equals -5. And now I'm just going to combine my like terms. So I could pretty much just basically either move the 6 to the other side or combine the like terms that I have here. Honestly, it's not going to make much of a difference. So what I'm going to do is I'm going to just say, well, -6y. I'm going to work with my like terms. I have like terms on this side. So -6y plus 5y. What I'm going to do is I'm going to add that because, well, -6 and +5 are like terms, and that's going to be 6. I bring the 6 down. And negative 6 plus 5 would be negative 1y, or minus y, if you like to write it that way. I wrote negative 1y just for the benefit of those people that are like really visual. And then you bring down the negative 5. And now I just move the 6 to the other side. So technically what I do is, since this 6 is positive, I subtract 6. I subtract 6 here as well. And this is going to cancel out, of course. And that's going to leave me with negative 1y. And I'm going to write it down here. Negative 1y equals negative 5 minus 6 would be negative 11. And then I'm just going to divide by negative 1 on both sides. So this is going to be negative 1 and negative 1. And this is going to cancel out. So negative 1. So basically, y is going to equal, well, negative 11 divided by negative 1 is going to equal positive 11. So y is going to equal 11. Now, I found one of my variables for the system. I found one of my variables for the system. I found one of my variables for the system. I found the value of y. Y equals 11. So the third step is just to find the value of x in this case. So step number 3, I can do it one of two ways. I can either plug in the value of y into one of the two equations, or I can plug in the value of y into the expression that I got. So let me highlight that for you guys. So I can take the number 11 that I got down here, and I can either plug it into one of these two equations, or I can plug it into this expression that I got in step number 1. And the easiest way is just to plug it into this expression, because it's already solved for x, and it's going to give me the value that I need for x, and that's going to help put an end to the exercise. So basically, x equals 3 minus 3y, where 3y is going to be 11. So basically, that's going to be x equals 3 minus 3 times 11, and 3 times 11, right, is going to be 33. So basically, x is going to equal 3 minus 33, right? Again, I just plugged in the numbers, and I bring down the 3, and 3 times 11 is 33. So this is going to be 3 minus 33, which is going to equal to negative 30. So that means x is going to equal to negative 30. And that is the value of x. So that means that the ordered pair that would satisfy this system is negative 30 and positive 11. Negative 30 and positive 11, because x is negative 30 and y is positive 11. And just like we did in our previous video when we were solving systems of equation by graphing, if I wanted to check my answer, I could pretty much take the negative 30 and the 11 and plug it into the equations, which is what I'm going to do just to illustrate it, but not before going over the steps that I did. So I look at my equation. 2x plus 5y equals negative 5, and x plus 3y equals 3. And I want to solve for one of the variables, either x or either y. In this case, I chose to solve for x just because if I notice the x has a constant of 1 in front of it, so it'll just be easier. So this first step is to take the equation x plus 3y equals 3 and solve for x. So I subtracted 3y on both sides. This side cancels out, and I got that the expression or the variable solved for x is x equals 3 minus 3y. Once I got that, what I'm going to do is plug in this equation into one of the two systems. The easiest would be to plug it into the first one. Okay, so I'm going to take x equals 3 minus 3y, and I'm going to plug it in here. So that means that instead of writing 2x plus 5y equals negative 5, I'm going to say 2 times, and then I change the value of x into this expression, which is 3 minus 3y, and I bring down the plus 5y, and I bring down the equals negative 5, and then I just use my distributive. So 2 times 3 is 6. 2 times 3y is negative 6y. I bring down the plus 5y. I bring down the equals negative 5. And then I just combine my like term here. Negative 6y plus 5y equals negative 1y. So I brought down the 6. I brought down the equals negative 5. I solved for y by simply subtracting 6. And this side, and I subtract this on this side. So obviously this is going to cancel out, which leaves me, and then I just pass down the negative 1y into the final step. And then negative 5 minus 6 equals negative 11. I divide by negative 1 on both sides, and I get that y equals positive 11. Now I found the value of y, so in order to find the value of x, I can take this number and plug it into this equation, or since I already solved this expression for x, I can just plug it in here, which is what I did. And what I did was then I said x equals 3 minus, instead of writing 3y, I wrote 3 times 11, and that would be 33. And 3 minus 33 equals negative 30. And that would give me negative 30 and 11. Now, if I wanted to check my answer, which is what I'm going to do now, I'm going to take the ordered pair that I got, and I'm going to plug it into both of my equations. Now, if I get the same value for each side, that means that this ordered pair is correct and it satisfies the system. If it does not give me the same answer, that means that probably there's an error somewhere in the process because the ordered pair does not satisfy my system. And sometimes simply it's because the system might not have a solution, but that in this case, we're just going to assume that there is a mistake in the procedure and we're going to go back to it, okay? So let me do this last, or this optional step, which is to check your answer. And instead of writing 2x plus 5y equals negative 5, what I'm going to do is, and let me erase this. So instead of writing 2x plus 5y equals negative 5, I'm simply going to plug in, change the value of x and y to the ordered pair that I obtained, which was negative 30 and 11. So I'm going to say 2 times negative 30 times negative 30 plus 5 times 11 is supposed to equal 5. 5 times 11 is supposed to equal negative 5. 5 times 11, and that's supposed to equal negative 5. Okay, and again, this step is optional, but of course, it would definitely be of benefit to those who actually execute it because it will give you an idea of whether your answer is wrong or not. So 2 times negative 30 is negative 60. So this would be negative 60. And of course, 5 times 11 is positive 55. So I have negative 60 plus 55. And of course, if I am adding integers, I'm subtracting, and that would equal to negative 5. So the first equation checks out, because if I have negative 60 plus 55, that would be negative 5. And of course, if I get the same answer on both sides, that means that this is correct and this checks out. So the first part checks out. Now we're going to see the second equation and if we get the same result. Second equation says x plus 3y equals, so x plus 3y equals 3. So I'm just going to change the value of x to negative 30. And instead of writing 3y, that's going to be 3 times 11 because that's the value that I obtained for y. So 3 times 11, and that's supposed to equal to positive 3. So of course, we're going to use our order of operations in this case. And we're going to say, well, negative 30 I bring down. And 3 times 11 is 33. So will this equal to positive 3? Well, if you have negative 30 plus 33, you subtract, and your answer will in fact be positive 3. So this is equals 3. And since 3 equals 3, ladies and gentlemen, that is correct. And this does in fact check out. So that means that that answer is correct. And this is how you solve systems of equation algebraically, specifically using the substitution method. Hopefully this video is helpful for you guys, and we'll see each other in our next class. So stay safe and bye-bye.